In this video, we will learn how to find out absolute own price elasticity of demand from the given utility function and budget constraint. The question is, a consumer consumes only two goods, X and Y. Her utility function is, that means utility derived from the consumption of good X and Y is equal to X plus Y. Her budget constraint is Px plus Y, where P is the price of good X. If price of good X is 1 upon 2, then absolute own price elasticity of demand is, the options are 0, 1 upon 2, 1 or infinity. So we have the utility function u x comma y is equal to x plus y. This is our utility function. And budget constraint is P time. Okay, in place of P, let's write it Px, okay, to make sense. Px times x plus y, and let's denote it by py times y is equal to m. Okay, this is our general budget constraint. And in place of px we have p. Okay, let me write it here. P times x plus, in place of py we have, since we have only coefficient 1 here, so py is here 1, we will not write it here. So m is our total income is equal to 10. Okay, consumer wants to maximize utility function subject to this budget constraint. Okay, now if I draw the graph, it will make more sense. We have unit of good x on horizontal axis and units of good y on the vertical axis. Okay, if I plot this budget constraint here, okay, let us say this is our budget constraint. Now what happens, consumer wants to maximize his utility subject to this budget constraint. Okay, so in place of p we have 1 upon 2, and let's write it here 1 upon 2. Okay, now since this is our utility function which is also linear, we know to find the optimal bundle, our marginal rate of substitution between good x and y should be equal to the price of good x upon price of good y. MRS is simply the slope of indifference curve, and px upon py denotes the slope of budget line. Okay, now what is MRS? MRS is simply marginal utility of good x upon marginal utility of good y. Okay, and slope of price of x upon price of y, this is the slope of budget line. And price of x is 1 upon 2, we have 1 upon 2 divided by price of y is being given us as, since coefficient is 1, so here we have 1. Marginal utility of good x means the partial derivative of this function with respect to x. Okay, if I take the partial derivative with respect to x, I will get 1. If I take partial derivative with respect to y, that is marginal utility of good y, it will come out to be 1. So here we have 1 upon 2. Let us see here. We have 1 and 1 upon 2. Here we can see 1 is greater than 1 upon 2. And this 1 is actually our slope of, this one is slope of indifference curve, and this is slope of budget line. When the slope of indifference curve is greater than slope of budget line, okay, so with given budget constraint we want to maximize utility. Slope of this budget line is 1 upon 2 and slope of indifference curve is 1. That means it will be stable. And let us draw some indifference curves like this. We have this kind of indifference curve. We want to achieve highest possible utility. So here you can see budget line and indifference curve. Let us say this is IC2, IC3, IC4. Okay, so this is IC1. With given budget constraint, consumer wants to reach to the highest possible indifference curve, and the highest possible indifference curve is IC4, where budget line and indifference curve intersects. So here we will get the corner solution. This MRS condition, this equality does not exist here. When this happens, okay, when slope of budget line, rather the slope of indifference curve is greater than slope of budget line, that means consumer will consume all units of good X. I will give another, you know, explanation also, and 0 units of good Y. So what will consumer consume? That means X will be equal to total income upon price of good X. Total income is 10, price of good X is 1 upon 2. This comes out to be 20. That means consumer will consume 20 units of good X and 0 units of good Y. Okay, so this will be the demand function when slope of indifference curve is greater than slope of budget line. But another simple explanation can be, since price of good X is less than price of good Y, okay, obviously good X is cheaper than good Y, and we have this linear uh, you know utility function. That means they are the substitutes of each other. By linear utility function we mean X and Y are the substitutes of each other. If price of good X is less than price of good Y, okay, why on the earth will the consumer purchase good Y? He will purchase all units of good X. Okay, so he will purchase all X and 0 Y. And it's another thing can also happen if price of good X is greater than price of good Y. At that point consumer will consume all Y and 0 X. Okay, so this is another explanation, but I was just trying to make it more, you know, sense with the graph. So this is the demand function of consumer. Since price of good X is less than price of Y, price of good X is 1 upon 2, price of good Y is 1. That means that means good X is cheaper, and we have the perfect what we call the substitutes here. This is the demand function. Now what is own price elasticity of demand? Simply elasticity of demand is being given by, that is uh, change in X upon change in price of good X times price of X times units of X. Now dx upon dp means taking the derivative of this function with respect to price of X, which implies if I take the derivative it will become minus m upon px square times px divided by x. m is being given us as 10, which implies we have 10 divided by px square. So px is 1 upon 2, it is square, times px is 1 upon 2 divided by x. We calculated, it came out to be 20. Solving this, it will come out to be our ep will come out to be, so it will become 10 fours are, it will become 40 divided by 40. So we will get 40 divided by 40, obviously negative, so it comes out to be minus 1. That means absolute price elasticity of demand will be equal to 1. So the correct option should be this C option.